In this video, I'm continuing from the last videos where we solved this problem with broken machines that can be broken for multiple days, and we want to find what was the first day the machine broke and what was the last day it got fixed. It broke on the 19th and it was still broken on the following Monday, meaning I want these four columns to be connected into one. And we can see the output here, which is what I want to create. In the third solution, I want to do this using a recursive lookup instead, because that's fun. I'm going to start out by referencing the data table, and as before, I'm going to unpivot based on the ID column. Each time the machine is broken, we get a new column, but unpivoting other columns means we only have to reference the column we unpivot based on, which means it doesn't matter if we add more columns, and that's very convenient. Unpivoting also deletes rows where we have null, which in this case is something we want, because that's simply because this machine only broke once and this machine broke twice. And like in the previous solutions, we don't need the attribute column, so we'll delete it. I then want to sort my table, first on ID and then on the value, which is actually the failed date. And I want to go back and change the name as I did in the previous solutions. And then the sorted rows is going to be mad because I changed the name. That is then fine. I want to add an index column, this time starting from 0. Because when I do a lookup, it's actually a list lookup, and lists start from index 0. So the first row has an index position of 0. As before, I need to check whether I have a machine broken on a Friday, and then it's also broken or fixed on the next Monday. I want to extract the day of week, and I want to start from Monday. And then because I don't want Monday to be 0, I want it to be 1. I'm going to add a 1 to it. And actually I messed up my sort, I can see. I want the failed date to be ascending, and now it's fine. I'm going to copy in the same function because nothing has actually changed yet with this solution. Then I need to change whenever I do a reference to make sure I actually reference the previous step. Then I can see I'm still doing it because I called the column day of week with a capital W instead of with a small w. We're going to change that, and then everything is fine. And again, when you have errors in your column and you update the column, it's going to still show the error bar. But if we go to a previous step and then the current step, this updates. Nothing has changed so far, but now is when we want to do a recursive lookup. I'm going to add a new step, and because this is recursive, I want to start out by changing the name of the step to whatever I want the function to be called. I'm going to call that function recursive lookup and then copy that. In this first initial function, I'm going to hardcode values, which is of course a bad thing. Then afterwards, I want to update the function. But this initial function will make more sense to understand the logic. This is going to be a function that takes a row as an input, or in other words, a record. And we can specify that using the asRecord word. I want to output, and then we'll add the commentation that this is hardcoded, which means when I reference the table, I need to remember to call it custom1. Then my function is going to be, I want to do a lookup into the current row. I need to do a lookup into my current row with a column name of same ID plus previous day. And because I have a plus sign inside of my column header, I need to use the hashtag quotation mark syntax. I can ask if this is equal to same ID plus previous day, then I want to do a recursive lookup, and we'll do that afterwards. I first need to make sure I have an exit condition. I'll start out by adding that. If the value of this lookup is instead equal to no, then I want to grab the failed date of my current row. And lastly, I need to handle errors. And I'm outputting the text error instead of an actual error, the value error. And I'm going to do line break to make it a bit easier. Then I need to reference the name of my function, and I need to add the add sign in front to say it's recursive. And then my actual lookup is then going to go into the table called custom1. And then I need to access the record because my function takes a record, and this is then current row, which means I have access to all of the values inside that row. And I need the index column. I want to access that. And actually I need this not to be square brackets. I need this to be curly brackets because it's a list lookup. So I need that there. I want to go into the index and then add +1. So I check the next row, and then I need to update my comment to say, and then I need to keep checking until I eventually get the last one. Because here in my first row, I have no, which means I want to output the failed date value. In this second row, I have same ID plus previous day, which means I want to keep checking the next row until I get to the last time I see this same ID plus previous day, and then I want to get the failed date. This follows a similar logic to the group local function, where we'll add a new column that gets the last day where the machine is broken. And then if I did everything right, which I didn't, and then I need to check my parentheses, and I don't need a square bracket there. And I actually need a then here, and then actually I need to output something, and this is where I messed up. I need to add equals to no. Then I want to output that. Otherwise error. And I don't need a closing parentheses because this is a function. And then because I specified that the current row is a record, I don't get an option here, like a normal value you can input, but that's fine. You can then go into the custom one table. Then I want to apply a function. And I can't call it with this invoke custom function button because it expects a function as a query, whereas I have a function in a step. What we can instead do is to say I want to add a new column to the previous step, and that should be called last fail date. And then my function is for each row, I want to use the function recursive lookup, and I want to input the underscore because that's then the entire record, and then I get what I expect. So here in my first row, I get the value of same ID plus previous day, which means it's going to check the next row, which is also same ID plus previous day, and check the next row, check the next row. This is then equal to no, which means I want to grab the value in the failed date. And I'm going to say this, which I do every time I do recursion. Try not to use recursion because it's very confusing for the reader, because I have to look at this and then understand and keep in mind that it's recursive and I can't see what's going on in the actual table where I apply it. I need to look at the table and the function at the same time in order to understand what's going on. I will go so far as to say that best solution is never a recursive solution, but it is very clever, which isn't actually a good thing. The only thing it's good for is that it's very few lines of code. And I can't imagine it's very good for performance either, because for each of these 3 rows, you actually do the same lookup. In the first row, you check the next row and the next row and the next row. In this row, you check the next row and the next row, and it just keeps going. You end up doing a lot of unnecessary lookups. So this solution is not good. I would recommend the group local if you expect your coworkers to be familiar with the groupkind.local function. Otherwise, use FillDown. Actually, I want to add that the output of this function is a date, but now we can do the same thing we did in the FillDown solution, which is I want to remove duplicates, want to grab the ID and the last fail date and remove duplicates. And again, I want to wrap this in table.buffer because I have bad experiences with removing duplicates from a table without adding table.buffer. I'm going to add the same sort order step in order to get the same output as in the link I showed. We can sort based on that. And then I also want to sort on the fail date in ascending. Again, we need the ID, fail date, and the last fail date, and delete everything else. Then we get the same output. The problem with this function is then that I've hard-coded the table name. I've also hard-coded the columns, and that's not very good. I'm okay with hard-coding the index column because that is most likely what you're going to call it. If we go through the function, we can see that I reference a table, I reference a value. I'm okay with keeping this hard-coded, but you don't have to. I'm also referencing a value here. And again, I'm going to keep these hard-coded. Also reference an index column and a value column. In order to make this function variable, I need to add a lot of extra parameters, which is a bit annoying, but it's not that bad. I need to add a table lookup. I need to add my condition field, my index field, and my output field. And the only tricky part is that when you create your own function, you can reference columns using the square bracket syntax. You need to use the quotation mark syntax, which means I have to change some of the functions. But conveniently, instead of doing the shortcut syntax to do a lookup into a record, I can instead use the formal function, which is then called record.field. And the record I want to access is the current row. And the column is then no longer hard-coded. It needs to be called the condition field. And I am spelling that wrong. Yeah. And then I want to close parentheses. And again, I'm going to hard-code this, which I'm okay with. But you could just add that as another parameter. But I already have 5 parameters. I don't want to have 7. And then this is the same. But again, I can't reference the index column in the square brackets either. I need to use another function. But conveniently, this is just a shorthand syntax to filter a table. And because I know that the index column is unique, this will return 1 row, which is what I need in order to do this lookup. I can do a normal non-shortcut filtering of a table using the select rows function. Instead of using the hard-coded value, I need to use my parameter, and then my function is each. And since I need to access the index field, I can again use the record field function. And then in the table select rows function, I have access to the underscore. Through my each function here, I can then say each. I want to select the value inside of the index column, and then I need to copy that parameter, and then I need to add 1 to it. Now I need to mind my parentheses. This is going to extract the value 1. Then I want to add 1 to it in order to access the next row. And then after the parentheses, this is going to return a table, but I don't want a table, I want a record. And I know because index field is unique, that means this lookup will return 1 row, which means when I do curly bracket 0, I get that 1 row, which is a record, which is what my functions rely on. This is fine. Then I need a comma. And then I need to pass in all these other values inside of my function because I'm still actually inside the function in my recursive lookup. All this first part does is grab me the current row, which is then actually the next row. And then I need to pass in the other fields, which are unchanged. I can then say, actually, I want to remove this here. Say get next row. And then I copy down that comment. And then again, in this if, I need to change this to a formal record field lookup where I say current row, comma condition field. And if that is equal to no, and then I need to mind my parentheses, then I need to use record.field again to access the current row, comma failed date, which is then my output field. I need to also go into the function call to change that, because now I have a lot more parameters. So I need to say still the underscore because that's my current row. And then the previous step is called custom one. And fortunately we get intelligence here, and that's why you need the descriptive fields. My condition field is called same ID plus previous day. And my index field is called index. And my output field is then called failed date. And if I did everything right, cross finger, I did not. Actually, I can see here I messed up in the actual recursive call. I need to say each record field underscore comma index field. And then I need to say if that is equal to record field, current row, comma index field, current row, comma index field, and then +1. And then we try again, because I actually forgot to check the condition. I'm saying go into the table lookup and filter that, where here I use the underscore because I iterate over my table. And then I want to filter the lookup table such that I get the next row. And this part confused me a bit because I'm doing 2 record field lookups. But here I'm actually saying I want to filter the table based on the index field, and the value in the index field need to be equal to the current row sys next row. And then I'm doing that extraction because I know table.select rows will give me a 1 row table, but I needed to output a record. So that is fine. And then everything else is the same. The only distinction between these two solutions is that here, this is not hard-coded, this is variable. Unfortunately, in order to be variable, I need a lot of parameters. You could probably hard-code the output field, and you could also hard-code the index, and you only have 3 parameters. You can decide for yourself if that's easier. You could also add the values that you need to compare as parameters, but then you have 7 parameters. So it's all up to you what you think is easier. But I would not recommend using the recursive solution. I would recommend the FillDown solution. It is way easier to understand. So